Hello everyone. So we are back today in cybersecurity news, and today's topic is Exodus malware from Italy. So before we start this topic, I want to request everyone to like this video and also subscribe to the channel so that we can make more such videos going forward. So few cybersecurity researchers have discovered an iOS version of this powerful malware for phone surveillance that was initially targeting Android devices through apps on the official Google Play Store. This is dubbed as Exodus because this name comes from the command and control domain name used by these hackers or surveillance company, and the iOS version of this spyware was discovered by the researchers while they were looking out or doing the analysis on the Android samples of this malware starting from last year. But unlike the Android version, which was only found through the Google Play Store, the iOS version is not actually being distributed by the Apple Store. It's distributed by emails or malicious websites. So in summary, this malware can exfiltrate information from the Android or iPhone devices, which includes contacts, audio recordings, phones, videos, GPS location, and the device information. So instances of this malware or the application were found on Google Play Store and were in Italian language. The applications were in Italian language. There is more research done by the researchers to show it's coming from which company and which company is developing these applications. As per the current information from Google and publicly available information about how many times these apps are being downloaded yet, for now it's a few dozens for few of these apps, and in one case for one app it reached also 350 downloads. All the currently impacted victims are in Italy, and from Google these applications are already taken down. So for now they look the Play Store looks clean from this malware application. Okay, so that was the summary, and now we will go a bit deep on how this malware works and how much impact it's causing on what all information. So it's believed that this spyware or malware is developed by an Italian company called ESURV, as you can see on the screen. This company primarily operates in the business of video surveillance, and according to the public record, it appears that ESURV began to develop the intrusion software in 2016. So you can see on the screen, the first step is to upload this malicious application or spyware application on the Google Play Store. That's shown from eServe going to the Google Play Store in this diagram. Then as a step 2, the user's mobile, be it Android, we're taking example of Android, so not iOS. So for Android, this application will be downloaded by the user from Google Play Store on the left side and going to the right, which is a user mobile. And then from the user mobile, the direction of the traffic will be from user mobile towards the command and control server, where the hacker tries to get the basic information from this dropper malicious app, so the different kind of information the CNC will try to get will be application package name, IMEI number, and the phone number. Then in the next step, the user agent string is built from the package name and the IMEI number. Finally, the HTTP request is sent to the server, the CNC server, and some additional requested information is also sent from the dropper with the post request. Then, as seen in the screen, the dropper will make a post request to the CNC command and control, as you can see, and the command and control will return a zip file containing the second stage binary. So that's when the Exodus 2 starts. Till this point, it's all Exodus 1, where the CNC is trying to upload the zip file with all the required tools and malicious files to the phone. The initial part was just to get the basic information from the phone and give it to CNC, and then CNC will send the zip file, as we're going to explain what all is in that zip file. So on the screen you can see list of files in that zip file. The important files are null files and the mic.jar file. I'll explain what this jar file will do, and the root daemon file. So I was talking about mic.jar file. So this mic.jar file implements most of the data collection and exfiltration capabilities of this spyware. Then the next important file is the null file, which is on the screen. You can see null_arm or other different versions of null file, which serves as local and reverse shell. And then the root daemon, which is also on the screen. You can see root daemon_arm 64. So root daemon takes care of privilege escalation and data acquisition. Root daemon will first attempt to jailbreak the device using a modified version of the dirty cow exploit. Additionally, Exodus also takes advantage of a feature called protected apps, which is a feature in Hyundai phones that allows to configure power saving options for running application. So by manipulating a SQLite database, Exodus is able to keep itself running even when the screen goes off and the application would otherwise be suspended to reduce the battery consumption. And the root daemon attempts to remove its own power usage stats from the Hawaii phones, which is very useful because then users wouldn't be able to figure out the power usage. So going back to mic.jar file, which actually equips the spyware with the extensive collection capabilities. On the screen you can see what all data it can collect and exfiltrate back to the CNC. So just to name few of them, it can retrieve list of installed applications, it can record surroundings using using built-in microphone in 3GP format. It can check the browser history from Chrome and other browsers, extract events from calendar apps. So pretty much everything on your phone, once this spyware is installed, can be captured and then exfiltrated to the CNC. So in the earlier slide you saw some of the information which mic.jar can easily capture and send it to CNC, but some of the information on the phone needs extra privilege access, and for that the mic.jar connects to or takes usage of the root daemon file, which was root daemon tool, which was also shown on our screen earlier. So some of these files are saved on the SQLite database in the applications storage and are actually transferred through root daemon, which should be running with the root privilege. So in order to achieve this, mic.jar connects to the root daemon through various TCP ports that are shown on the screen, and the daemon binds on some extraction routines for supported applications. So you can see the first port is the WhatsApp extraction service, then the Facebook, Gmail, Skype. You can see different ports which the root daemon can use to connect with the mic.jar file. So these services appear to be running on all the network interfaces and are therefore accessible to anyone sharing a local network with the infected device. So eventually the researchers also observed that the Wi-Fi password was sent to the command and control center pretty easily in plain text, and this command and control seems to have been active since at least April 2017 and was registered impersonating the legitimate service AccuWeather. So we have already covered the mic.jar and the root daemon important files, but there was a third file which I mentioned at the starting, which was null files. So that's used for local and remote shells from CNC. So in order to execute the commands on the infected mobile devices, as well as to provide a reverse shell to the command and control operator so that they can manage the commands. The Exodus 2 immediately attempts to execute a payload. It downloads with the name null. That's the null I was mentioning earlier. So this payload will then attempt to start a remote reverse shell to the CNC on port 22011, which is a configured port, and it can be different. This remote reverse shell does not employ any transport cryptography, so it's plain text, and the traffic is clear and is therefore potentially exposed to man-in-the-middle attacks. Same time, null will also bind a local shell on 0000 local port, local interface on port 6842. This local port is used by Exodus to execute various commands on the Android device, such as enabling or disabling any services the CNC wants, or parsing app databases. Actually, binding a shell on all available interfaces will obviously make it accessible to anyone who is sharing the local network, or if it's in the cellular network. If it's not Wi-Fi, if it's a cellular network, then it is exposed to anyone in the cellular network, because the IP and the subnet range is saved, is shared. So how the researchers found or decided that it's from eServe, actually 2 points. One is presence of Italian language, and the other one is overlapping infrastructure with eServe surveillance cameras. So the presence of Italian language was in the code, which in the classes file, which researchers could easily find and confirm that it's something Italian. Also, they found in the ZOR key, they found Rino Gattuso name in the character fields, which is a famous retired Italian footballer coming from Calabria. So that was one point. The second point was the infrastructure. So eServe, as I was saying, it's surveillance. They provide surveillance cameras to Italian users, and this CNC, which was 5469.156.31, as found by the researchers, actually had a self-signed TLS certificate with a common name MyCert and a fingerprint. The search of this certificate fingerprint on internet returned 8 additional servers, and doing more research on these 8 servers, users can confirm that the researchers can confirm that it's actually belonging to eServe. And also image search for the favicon favorite icon on Shodan using the query for the hash returned around 40 web servers which use the same favicon as the eServe. So that concludes that it seems it's coming from eServe. As an additional information, there was a public resume which confirms the development of this Android agent by eServe SRL. So there was a white hat security researcher who confirmed that he or she was developing an agent to gather data from Android devices and send it to the CNC server. Also, he or she was doing research on vulnerabilities in mobile devices, mainly Android, in a publicly available resume. Okay, so that's pretty much for this video on Exodus. If you like it, please share it and also comment on this video for future improvements. We'll be back soon with another topic from the daily cybersecurity news. Thanks for watching. Have a good day. Bye.